Hello, this video is to explain the use of a sodium hydroxide solution to identify unknown metal ions in solution. Now, I appreciate this is something that you've clearly, as a typical teenager, been wanting to find out how to do for literally all of your life. You've often looked at colorless solutions and wondered if there was a simple way that you could determine which metal ions were in this solution. And now you're about to learn. It's about as good as it gets. So, seriously, for the specification, you have to know how to identify up to 6 different types of metal ion which might be in a solution. Now, there are real-world uses for this, perhaps as a polluted water source, and we need to understand what's in there to understand how we could then clean it up. So what I've got is a solution, and there's a mystery metal ion in it. And what you would do, practical, you take some sodium hydroxide, and you add it. And as you can see, I hope, look at that. What it will look like on your screen is that it's gone cloudy. Now, there's a new word for you. It is precipitate. And what that means, this cloudiness, is because there's a solid forming in the solution. And it's a little bit like a snow globe, where actually it's already settling down. So I'm going to leave that, and hopefully right at the end of this video, we're able to see that there is a white solid that has formed in here. So let me show you what you need to know. Okay, so this is 4.8.3, identification of metal ions with hydroxide ions. And there are 6 different metal ions that you need to be able to identify. Copper 2+. Now, these Roman numerals, for the transition elements, the ones in the middle, they can sometimes make more than one ion. And to know which one it is, they use the Roman numerals. II for 2, and then down there for iron, III for 3+. Magnesium and calcium are in group 2, they do 2+. Aluminium in group 3 does 3+. So what you need to know, adding sodium hydroxide solution to other solutions which have metal ions in them can produce precipitates, and that was what you saw, this cloudiness. It's a solid formed out of the solution. You need to know the color for all 6 of these. So I'm going to talk them through, but what you will have to do is make notes, pause the video, write these down, and then just practice until you learn them. It's not glamorous. If they made a movie of your life, this would be a montage where they'd play some funky music whilst you excitedly go from not knowing it to knowing it. But in the real world, just keep going over it and over it and over it until you can tell anyone at any time. So copper 2+ gives a blue solid, a blue precipitate. Iron 2 is green, and iron 3 is brown. You might sometimes get away with saying orangey brown. It's a rust color because it's rust that is essentially iron 3. So those are the 3 that are distinctive. Cu blue, Fe2+ green, Fe3+ brown. There's one wee problem. Magnesium, calcium, and aluminium all give a white precipitate. So this is the limitation here. If they say that the student has a mystery chemical and they add the sodium hydroxide and get a green precipitate, boom, it's iron 2+. Brown precipitate, boom, it's iron 3+. White precipitate is a bit trickier. It could be any one of magnesium 2+, calcium 2+, and aluminium 3+. However, there is one extra thing you can do. If I were to keep adding sodium hydroxide and the white precipitate dissolved, then we would know it was aluminium 3+. Now, I know, because I made this up earlier, it is not aluminium 3+, and I'm running out of space in my beaker, so I'm not going to keep going. But if I was to, this would not dissolve. So I'm hoping you can all look now and figure out which 2 possible elements could be in here. Well done if you thought magnesium or calcium. This is, in fact, a magnesium ion that was floating in there. Okay, so that is that. Thank you very much.